All right. So thanks everybody for joining on this 11th September meeting of Aerial Robotics Working Group, Community Working Group. So today is going to be a discussion developer meeting about a topic that we've selected in the past, which in this case is going to be simulation. So I'm going to host. I'm Kimberly McGuire from Bitgrace. Ramon Roach will be on the back end, although if his voice allows him to.
Hey, thank you, everyone. Thanks for joining us.
Yeah, thanks a lot for joining. So like I said, like introduction topic is yeah, it's simulation. So I'll just have like a little bit of an intro for that. Then very easily we're just going to have a discussion about that, where people can kind of like express their difficulties with the simulators for aerial robotics or like things that can be improved, and then we can kind of discuss about things in general. And then like conclusion, a couple of announcements, and then we're just going to have the announcement for the next meeting as well. So this all will take just should be within an hour. Yeah, so simulators for aerial robotics. Well, there are already a lot of simulators out there, obviously. Like Gazebo is one of them. My favorite also is like Webbots. This is the one from the Ladybug, and most of them kind of support some kind of aerial dynamics. So, which means is that they're able to have something that's able to fly in the air. Um, and people use it for different purposes: for vision-based navigation to try it out first on the simulator, for control-based design, or swarming. And each of these simulators kind of need a different set of, yeah, how to say, qualities tailored to the application or topic. And that is perhaps also something that we can kind of discuss now, among other things. Like I made a list of simulators. Like you can find them in the Aero Robotics landscape. Perhaps Ramon, you can maybe share the link for that for in the chat. Where
Yep,
we
1 second.
where we already have a couple of simulators out there. There's many more, but kind of like the basic, of course, Gazebo is like a very stable one that people use. Webbots also has quadcopter dynamics in there. ESAC Sim from NVIDIA, that is starting to be quite popular these days. There's also like simulators that are meant for aerial robotics, like AirSim from Microsoft. Although they're going to deprecate that soon, or they're not going to longer maintain it. And from the piloting training community, somebody also mentioned in these like flight gear and X-plane. I've never tried those before. From the RC, the remote control community, people tend to use real flight simulator. And for reinforcement learning, you have PyBullets and everything, and they have quadcopter dynamics in there as well. I guess like maybe I have a nice poll out for you guys to maybe fill in which simulator you're using at this moment. If you go to the, I've launched a poll right now, which is, oh yeah, Vignesh, you're right. Unreal Engine is missing. However, that's actually perhaps something also kind of like something different, but you can make a PR, of course. So I'm now kind of talking about like robotics simulators where things are kind of like enveloped in one, like physics simulator, rendering simulator. Although Unreal Engine has it as well. Is everybody able to see the poll though? So like if you go to the yeah, the triangle, square, circle, there should be like a poll available that you can kind of like vote which simulator you use. I see 2 votes already, but we have more people. I'll guess the vote myself too. Right, we have 6 votes, 7 votes, 8 votes. Oh yeah, of course. If there's anything missing in the list that you're using, of course, send us say that in the chat. Like the MATLAB UFE toolboxes. Indeed, I'm aware of that. I think I've tried that one really long time ago, but I don't know what the current state of that one is. Yeah, let me just end the poll right here then. I see 9 people. 9 people for the votes. Oh, somebody said that Yeah, there should be multiple options for this poll. I agree. Unfortunately, that's not really an option, I think, in these polls. But just use just select the one whatever you're using right now, and that is fine. So if I can see, like most of you are still using the old gazebo, and then after that the new gazebo is mostly being used. Webbots is only one. That's probably me. And somebody actually is using PyBullet. But yeah, I'm actually surprised because I thought it would be more wide range. But as somebody already said, it would have been easier for people to actually have multiple options out there. Okay, so at least that we have kind of have an idea that gazebo is very widely used in the aerial robotics community, at least from you guys. Then there's also, of course, like simulation packages that either they support ROS or they don't. So Rotor S is the like a ROS1 package that many have used. That was developed at the University of ETH Zurich, and then you have Flightmare. Um, Also, I think that's also only ROS1. Yeah, Jim PyBullet drones based on PyBullet as well, Pegasus Simulator, and there's probably many more out there. So, but this is currently in the list. And if there's anything missing, or if you know of any other type of simulator package, kind of that combines also like the middleware things with that, and perhaps also that you're able to switch between the real thing and the drone, like you just of course, let us know in the chat. There's also a couple of nice comparison papers out, although there's not really one specifically for aerial robotics, but it's just for robotics in general. Yeah, so there's a couple of these comparison papers where they actually list several simulators that are suitable for aerial robotics. And I've also co-organized an 2023 ICO workshop, the role of robotic simulation in unmanned aerial vehicles. And hopefully that will so like there's going to be a paper about that as well, so hopefully we'll have a specific review paper about that. Yeah, so kind of discussion topics. Very quickly, I would say let's start with some kind of initial thoughts. What are your experiences with these simulators? Like, like what do you like, what you don't like? Yeah, what is important for the simulator for you, like rendering versus dynamics model versus parallelism. Is also like parallelism. I mean the like more kind of like the swarming capabilities. What is more important, and whatever kind of color comes up with it. So let's kind of have an open discussion about this. Yeah. So like initial thoughts. What are your experiences with these simulators? So yeah, like for instance, like a lot of you use the old gazebo. Like in terms of what is your experience with that? Like, do you like it? You can use the chat, or you can just say comment. Yes, go for it.
Yeah. Can you hear me all right?
Yeah, of course.
Yeah. So I mostly use the old Gazebo, and one good thing about Gazebo is like there is a plugin system that makes it very easy to use if you want to develop anything like custom physics module or something else, apply some effect or do something. So that is like the easiest way to connect with the cross middleware and doing things. So that's why the Gazebo. And I also work with some of these like flight gear, and so flight gear mostly I use backend where JSV sim is used. So with that is also the working principle is kind of similar. They have model files and they have plugins, but yeah, so that is the my simulation experience till now. I also tried PyBullet for the reinforcement learning, but the PyBullet when I tried it was only used for reinforcement learning. There is nothing else that you can do. That is just like you just want to fly a quad rotor and do
All right.
controls using RL.
Yeah, that could be the case. Like I put PyBullet in there because there's this Jim PyBullet drones that
Yeah, so
kind of
that
builds
is the
upon it.
one I'm talking.
But maybe actually that Jim PyBullet drones makes it actually capable for for drones specifically. So yeah, that's maybe yeah, maybe I should change it up. Is there also a particular reason why you're not using the new gazebo yet?
So I am still in between to transitioning to ROS 2 completely. So that's why I am stuck on the old gazebo. So probably in a month or two, I'm trying to move from ROS 1 to ROS 2. So then I will be switching to the new gazebo.
All right. Is there anybody that is currently working with the new gazebo that have any comments on their experience with it? With area with flying in a quad rotor in there or something like that. Not everybody at once. Let's say I've been mostly kind of dwelling around the webbots myself now these days. But I noticed when I tried out the new gazebo about in half a year ago or something like that. There were actually a lot of messages that weren't really implemented yet, because you had rotor S, which was then kind of integrated into gazebo, so at least this ignition messages were taken over from that as well. But that hasn't been that wasn't transferred at that point to the gazebo new. I'm not sure what the current state of it is. I don't know if anybody has any experience in that. Nope. All right. Okay. Anybody else that wants to kind of pitch in their experience, experience with the simulators, or if you have anything that you're unhappy about, improved? Yes, go for it.
Yeah, hi. So I basically I just want to add one comment before that. Is Rotor TM also a part of Rotor S? Because I saw Rotor TM was also developed by one of the universities, so I was not sure whether they were also.
Rotor T. That's a good question.
Yeah, I saw a few papers about them, like some 2-3 papers on them. It was developed by, I guess, University of Washington. I'm not sure.
I'm
Yeah.
actually not aware of their simulator, to be honest. I know Rotor S, but Rotor T, yeah, it kind of rings a bell, but I kind of thought it was the same thing, but it's apparently not the same thing.
Okay, I was thinking that probably it might be the same thing. Yeah.
No.
So, yeah, one thing that's a bit confusing for me is basically we are talking about a lot of simulators, right? And I see most of them use Simulink a lot as a starting step, mainly from academics. Yeah. Yeah. So, and other simulators are also useful for other stuff. What I would like to know is that what makes them different as a very contrasting feature of generally when you start using basic MATLAB Simulink model, and then you start going to any simulation platform. What makes it so different?
Yeah, it's that's a very good question, because a lot of people are confused, and sometimes I'm confused about it as well. At least from. Oh yeah, Roman, yeah, go for it.
I think that's part of what we're doing today, just trying to figure out what sets them apart, and starting from the perspective of the people that are actually using them, so that we can go from there. Hopefully, as part of the landscape, we can provide this information to everyone else and answer that question. But I agree that a lot of these simulators seem like the same, and in reality, the core principles behind them are not the same. And I think that's what we should be trying to figure out in the work group.
Yeah.
Sorry, my voice is getting terrible.
Oh yeah, no worries. But it was a very great, the addition indeed. That is also something that we kind of want to discuss. What are the differences between them? At least Simulink, what I feel that is kind of a simulator for is more for control theory and some basic dynamics. Which is also a simulator. There's a lot of simulators out there for different purposes. I guess we are kind of maybe missing is like, what is an aerial robotic simulator? Should it consist of? Like, at least what if I think about the simulator, I think about Gazebo, which has a basic dynamics model, it has a basic rendering, and of course, like, it has all the things that kind of pulls together. So it's not really one part of the simulator, it's kind of like a combination of a couple of simulators, let's say. And that's why also somebody also mentioned Unreal Engine, and I kind of more see that as the rendering engine, let's say, which is a part of a simulator. But yeah.
Actually, that was also asked by me. That was
Yeah.
in relation to this. The reason why I asked is that recently I saw Simulink has a connection with Unreal engines. Specifically, you could bring in Unreal scenes. I first thought it was only for visualization, and later I learned that it can also be used for physics dynamics also, like collisions and also other forms of interactions. And I was surprised to see that. So the big question that confuses me is that, okay, so simulator has different parts. One is a physics engine, which is very important. Visualization, rendering, that's also important. And you bring in the dynamics of the object, that's also important. If you say 3 parts, and starting with a basic simulator like Simulink maybe, where you write the whole model and the dynamics of the system. So you kind of get the dynamics, right? And you miss the physics and visualization part. And visualization also, you could do it by some simple objects. But the major confusing thing is that it's if I just leave about the visualization part, it's hard to say that what's my need and what do everyone offer, and I don't. It's very hard for me to understand that. Yes, the first place.
Yeah, it's a quiet world, and I guess like it doesn't help that Unreal Engine also have their own physics model as well. But I guess like the physics model maybe is not very suitable for aerial robotics, so that's why you want to maybe replace that with your own model in Simulink, which is used a lot in control engineering. Mayank, before you want to maybe pitch in, let me just double check what the other people have said in the chat. Yeah, so somebody is saying like this experience with Clover-based, the old Gazebo simulator MATLAB UV toolbox have been great, especially when it's easier to set up the environment and run UVs in some real-world scenarios. I find ROS 2 and the new Gazebo not to be worth the trouble, but I'm happy running software in the loop sims in its existing simulators itself. Okay, so I guess like it's at one point people do have to move to ROS 2 and the Gazebo because support will drop and that will complicate things. But it seems like that a lot of people are actually quite happy with how the old Gazebo was handling things. The MATLAB UV toolbox, yeah, that's a really long time ago. But we should at least add that to the list if people are still using it, right? But thanks for sharing your experience. And somebody also said that I've been using Drake for accurate dynamics. So I guess that's a physics model or physics model for UAVs. So that should also perhaps also be on the list of dynamics models. That's also very interesting. Thanks for sharing that. Mayank, go for it.
Hi, can you guys hear me?
Yeah.
Yeah, I just wanted to emphasize that quite often we overlook the reproducibility of the firmware or the software interfaces. And in my view, like you were mentioning the components of what makes a simulator, I think that's quite often an understated part of it. Because if you end up having to rewrite your code, or let's say you only end up testing a very small part of your entire solution, it might be good for an academic exercise for a very small part or a new thing that you're working on, but might not directly transfer to a physical craft. And quite often closing that sim to real gap is also a concern while working with the simulators. So having subtle support, being able to directly use like a software emulation of, let's say, PS4 Autopilot, or using the exact same ROS interfaces for a companion computer that you would on your physical craft, might also be like an important requirement for what makes a simulator worth our effort and time.
So you're talking about how do you call it, like an accurate, like software in the loop or hardware in the loop capabilities, aren't you?
Yeah.
Yeah.
Yeah, so
Okay.
that there's minimal friction in terms of going beyond just whatever you're experimenting in the sim. And I mean, it all does boil down to what you're using the simulation for.
Mm-hmm.
But quite often, if it is in service of building a real hardware-based solution, that ends up being an often overlooked component in lieu of, let's say, accurate
Mm-hmm.
physics or aerodynamics and other aspects. So I feel like that should be given equal weightage.
Yeah, I think that's a very good, and that's definitely missing from the aerial robotics landscape right now. Like the simulation that's page is very minimal. But yeah, the real to sim is a very important question because it really depends indeed, like in terms of your application, what you want. Like for instance, um, if you want to make a new controller for a UAV. And you want to at one point implement for completely embedded, then I would say then then hardware in the loop might be even more important than perhaps like if you do some kind of like visual navigation, right? Like if you do visual navigation, then you need to have a very good rendering. But if you have a companion computer that can already pretty much run the same thing as on your main computer, then perhaps you don't need that much of maybe I'm cutting a lot of fingers of people that are doing visual vision based navigation. Is like simulation is not the real thing. Of course, like the best simulation is the real thing, but
Yeah.
you have to kind of start somewhere, right? I guess. Um.
Yeah, one thing. So PX4 is, I think, uses this POSIX kind of system. So uh, you can run the same software as you are running on the autopilot. It also offers HITL, all the things. So it is like they maintains the fork of ROTAS for the PX4 and then does all the stuff that can be directly translated to a vehicle. So that is one thing I wanted to mention.
Yes. Yeah, that's indeed a very good point. That's I think PX4 supports it, Autopilot supports it. Even I think also sorry, somebody was trying to call me. Yeah, like a lot of the main autopilots, they have some kind of some kind of support of software in the loop or hardware in the loop. We have a couple of more raised hands. Bonolo, you were first.
Hi, I just wanted to add Open 3D Engine to the list
Mm-hmm.
of
Yeah, of
simulators
course.
that we were discussing. Yes, so I haven't used it. It's fairly new, but there's a lot of big companies that are backing this project.
Okay, Open 3D Simulator. I'm just putting it in the chat so that we'll like we have
It's
okay.
Open 3D Engine.
Oh, Open 3D Engine. Can you perhaps like post a link in the chat so that we have some kind of how do you call it, paper trail? Because my capability of writing at the same time the notes and let's say and to have also kind of lead discussion is really really minimal. So I'm really how'd say like I'm relying a lot on the transcript. Okay, Open 3D Engine. Good, very good. Okay, let's take a look at that. All right. There was somebody else that had a hands up. Adesu, go for it.
Yeah, thank you. I'm actually one of the core developers of Gazebo, and
Hi.
hi. I wanted to just get if anyone has feedback on why they're not why they've been having trouble with the new Gazebo or anything like that. I'll be happy to take notes. So please feel free to share that. Also with Gazebo Classic, like you said, it's going to be gone pretty soon. If you're using ROS 2, the next version of ROS 2 will not have Gazebo Classic support, so it would be good to start thinking about migrating. So, yep, just wanted to throw that out there.
Yeah, thanks. I didn't know that you were going to that we have one of the core developers of Gazebo. Apparently, gazebos, the old gazebos, is used quite a lot. If you look at the poll, that's kind of like the main winner here. But yeah, it's indeed, as you said, it's good to 1 point change, and I have to 1 point also kind of give it another swirl, let's say, because a while ago when I tried it out, there were still a couple of things missing in terms of like the ignition messages, that were a bit, but yeah, cool. It's there was somebody who had his hands up still. No? Okay, nobody had his hands up. Great. Okay, so then we kind of I'm not sure if this, like, the experience of the simulators was the was the topic that we actually are talking about. I guess like some people already explained, like, okay, what is important in the simulator, or what is important in the simulator for aerial robotics? Like, what are the main qualities that is important for your research or work or R&D work? That's a question. I'm just putting it out there. Yes.
So for me, mostly I work with the autopilots, and so trying to deploy system from simulation to real life. And so for me, the most important things are like physics engine rate and accuracy of physics, and also if I'm testing some controller, so I want to, like, if there is, so in Gazebo, physics engines on a normal machine takes a lot of CPs, so I care about a lot, like if everything is going the way it's supposed to go and everything is making the right steps and all that. So that is like kind of important part for me. But from visual side, I also work with the visual systems. So doing simulation for a visual system is still, I haven't tried like Unreal Engine or other things, but in Gazebo, I don't know it would be a good thing or not. So I haven't tried that. So from visual side, I just put real hardware and try. These are the two things that I mostly work.
All right. So kind of like mostly control, but also a bit of vision based.
Yeah. So
understand.
Yeah.
And I guess maybe a question for you is that, like, is it important that the simulator is able to do both really well at the same time?
I think like simulating the real world vision systems is a really hard thing to do. So at least if there is a simulator that can simulate like initial things like basic exposure or realistic texture kind of thing, that can help in accelerating the research for the visual systems. But as such, if I want to deploy something, it is really hard to go from simulator to real hardware, because the real situation is sometimes gets really nasty and things are really different in real world.
All right, real to sim is very important. All right, that's a very good point. I guess, like, let's see, like in the chat family, like physics engines very important by Vinesh. Gravity for interaction, so it's not perhaps not maybe not necessarily like the control of it, but like, yeah, I guess, like, the control gravity, that's just one thing. So that kind of goes hand in hand. Anything that you would like to add to that, Vinesh? Are you only interested in the physics interaction, or is, like, is there anything more that you want?
Yeah, one of the things is interesting also with interaction with objects, not only the gravity, like as aerial robotics is expanding, the interaction with objects is gaining a lot of interest. And I find that there is no simulator which properly talks about that interaction with aerial robots interacting with objects.
Yeah, okay.
And that's one thing I found. I also looked into your like workshop, and
nice.
but I didn't find things on that. Yeah.
No,
Yeah,
those are still very rare. I must say that there's a lot of papers out there that are doing research on aerial manipulation with ropes between drones and things, and that they do like rope
yes,
dynamics.
exactly. I'm exactly so much interested in deformable objects like ropes and cables and things. Yeah, things like
Yeah.
that. But I never found any simulator in that, and see people are developing their own simulators, probably writing it on some MATLAB and finding their own simulators. But that's one thing I'm missing. And also with another form of interaction, like one thing is that I find interaction with water is something that is extremely actually not there. Yeah.
Ooh. I guess we have to go to marine, the marine working shop for working group.
Yeah, I did look at that, but yeah, they have some things on that, but not drones and water, or not drones and other objects. But I was not able to find it. Probably I didn't look at it so deep into that, but still.
Yeah, it's going to be very specific. It's like drones and water, because there is indeed work of drones for eventually at one point going into water and turning
Yeah.
into like a submarine type of thing. So those people also have very much difficulty in making a simulator.
Yeah. So I saw that what do they generally do is that they generally take water as a viscous medium, and they just say that it's completely viscous, and but that's not exactly what. But I see there's some research which is going on at the interface of interaction with the water, maybe picking some objects on the water.
Like that, yeah.
I have now found that.
That
Which is what I'm so interested in.
Yeah, I'm afraid that you probably have to write something yourself. That's very specific, but it's interesting though. It's a very specific application. But at least I hope that the aerial manipulation at least improves with the.
Yes.
I've seen a lot of papers now out there, so hopefully they will at one point converge and they will actually submit something for Gazebo, and then people are able to use it.
That's also something I didn't see, because with the aerial manipulators, both active and passive, I see people have used Gazebo to actually make their own manipulators, but I heard that that's not specifically tuned for those use cases. People build on top of it, but I haven't found any simulator which is specific for this use case.
Yeah, right. But it's all good input for the future. I think in your case, maybe if you post something on Discourse or something like that, or there's the robotic stack exchange, perhaps somebody can help out with that, because I won't be able to help out with this.
What do you say on Discord?
I would say not necessarily on Discourse, but more of maybe the robotic stack exchange, where you can ask ROS questions and robotic questions, and maybe somebody can kind of point you in the right direction.
Okay.
Yeah. But I think because those are indeed first, but there's supposed to be some work out there. But yeah.
Okay.
We probably have to kind of continue first. Yeah, because there was somebody that actually mentioned in the chat that somebody works with agriculture spraying drones, and he wants to simulate to be able to load environments as open drone map and be able to connect with multiple autopilots. That's an important characteristic, but I guess multiple autopilots, then you mean with software in the loop, I assume, right? SGN 047. Yes. I guess so. All right. Yeah, okay. So load multiple environments, I guess. Let me just also add that to the list. Load real world environments. Yeah, I'm probably going to re-look at this recording for sure. Okay, so there's a couple people hands. Mayank, go first. You also put something in the chat. Maybe you can.
Yeah, so I just put my point on firmware and settle there. So like simulation of software interfaces as
Hmm.
what I think is important. And since you mentioned parallelism in one of your previous slides for the case of swarming, I really think as we start to build swarming behaviors, network simulation will definitely be something which will be very useful for those use cases. So being able to see packet drops, reliable communication, and kind of integrating existing network simulators like NS3 into Gazebo or some similar simulator will be of a lot of interest, because this would severely hamper like how missions get carried out by drone swarms. So I think network simulation is something which we're not even
Hmm.
considering right now, because we're thinking of single drone missions right now. And when we come to parallelizing and not just doing multiple, the physics for, let's say, multiple drones and swarms, also how they talk to each other, how busy the chatter is, things like that will definitely have an impact.
Yeah, that is a very important part indeed. I totally agree. I'm a pop swarming myself, and I tend to forget the network simulation as well. Um, at least what I've seen so far, the only simulators that have like, of course you can write plugins yourself for networks. That's always possible, but the one that actually has network simulation out of the box is what I've seen so far is Webbots.
Nice.
Yeah. So, but of course, maybe there's more out there. But of course, um, there might be a more out there. But in terms of like simulators itself, they kind of like assume like perfect communication and no packet loss
Yes.
and perfect
Yes.
world. Yeah. So yeah,
No concept of quality of service or RSSI.
no
No
packet,
multi-path.
no packet collisions or whatsoever. Yeah, the
Yeah.
perfect world, and that doesn't
Even with
happen.
300, even with 300 drones.
Makes sense, right? Like it's magic. Yeah, it's yeah, that's a really good one, actually. Yeah, that's something to not be forgotten. But that is also something that a lot of simulators tend to yeah, ignore, let's say. Um, you also mentioned like network connection. I would also like to add that there's also a couple of simulators that actually simulate like the whole process of microprocessors and embedded systems as well. And that's really going hardcore, really deep. That you actually are simulating the behavior, yeah, of an STM microprocessor, for instance, like that. And that might go a little bit too far. Maybe it's fine to just be able to compile it for like the C program for the computer. But there's also a lot of things that actually go on in the interconnection I/O of that as well, and things might also go wrong there.
I think that comes down to the motivation. I think this was mentioned even in that seminar you shared, the workshop from ICRA,
Hmm.
where if you're doing it for verification and validation, whenever there's a safety component involved, you would want to simulate the behavior of the processing platform and how the firmware would react in certain corner cases down to the T. That's
Yeah.
where those sort of simulators would really play a role. But if you're looking at high level behaviors with some coarse understanding of the physics and things like that, and you're focusing on, let's say, path planning and your overall mission at a higher level, then maybe that's not the last thing you want to worry about. Or you do those things independently.
Yeah, exactly. Or maybe you don't. Maybe just go for the hardware input at one point.
Or
That's
exactly,
also possible. Yeah.
that's also one of the reasons to fall back onto things like
Hmm.
Cakes for Autopilot and RD Pilot and like tried and tested open source platforms which have come to a certain level of maturity. So that the basic flight characteristics, unless that is your specific focus of research, those things you don't have to worry about.
Hmm. All right. I think we had one more hand in the air. Gayandra, go for it. Or Gayandra.
Yeah. So one thing that I wanted to say is simulating aerodynamic effects, but not like very high fidelity level, but it's like uh, something like run system in the real world and transfer it to simulator, something.
Oh,
Because
so for instance, they actually do the experiments in real life, and then you try to kind of
yeah,
replicate the
generate the
same thing.
model like system identification kind. So if simulator can take identified system, that would be like I'm flying the real system if there is enough data.
That is a good point. So effects. Yeah, although like this is a very long time ago. Aerodynamics is very difficult.
Yeah. That's why I said system identification with enough data should be fine, because that can get very messy aerodynamics.
I have heard of work. I haven't really looked into it before, but it was really interesting that you have like that they do with deep learning neural networks, that they are training based on aerodynamic data, and that the network is pretty much the model that comes out of it, and that was able to do it quite accurate as well and very fast. So I'm not sure if they ever did something like that for aerodynamics though, but for collision physics they did. That's I really have to look into that. But yeah, it's a good point. I've put it in there. Let's see if there's any other problems. Like CGN is mentioning fun. I've had a lot of trouble with commercial available autopilots. Like I guess the JIYI. I've never heard about those ones. Is that DJI or? I might simulate something with peaks for autopilot, but I get different behavior in real life, and that is the problem with the use closed source autopilots. I guess maybe you're talking about DJI. So have anybody used run and software in the loop with commercial available autopilots or other than peaks for an autopilot? That's a question for you guys.
I did use one commercially available autopilot, but they are really, really expensive, and they provide full close support. Even you have to pay for the support, so I think that does not make sense here.
Were you also did you get a good like software in the loop? Did you get like a software in the loop possibility there for like a simulator?
Yeah.
Okay.
So mostly it was working with the Explain. So it was they had some models made for Explain, and Explain they are simulating it.
Right. Okay. And the Finesse aerial simulation uses showing external disturbances. I think that aerodynamic effects already holds. Tim is saying ability to easily define new vehicles. I'll put that also in the list. That's also important. But I guess like that's like easily define new vehicles. But I guess like the question is, the gazebo, for instance, is quite easy of defining a new one. But it's like, is it more of like building one from scratch? Perhaps like building a quadcopter in simulator. Is that what you mean, Tim, or just taking an existing platform, a simulated platform, and putting that into the simulator? Yeah, so Tim is asking, is gazebo easy to define new vehicles? Well, you can spawn new vehicles, but the vehicle needs to be already existent, and then you would probably also, if you want to have a new vehicle, a new model. Yeah, that is a good one. Because you would need to make either an URF file for that or an SDF file, and depends on how complicated your vehicle is. A quadcopter is pretty easy, but if you do a quadcopter with a arm on it, then it becomes a little bit more complicated. I must. Yeah. Oh, okay. So Tim is saying that it can be easily done in real flight, so that's interesting. I've had good experience with webbots myself when I tried to make a new vehicle on there. Gazebo, you kind of have to do that from the URF file, but perhaps Adiso, I don't know if you want to. Is there some kind of tool out there where you're able to make a new platform in Gazebo very easily? Like maybe like in a visual way or something like that.
Yeah, that part is definitely lacking from Gazebo. It's not. I wouldn't say it's easy to make models from scratch unless you know URDF or SDF. There are we have some tooling for, getting your assets like meshes and things into Gazebo, and then creating the joints there. And Gazebo Classic has that, and Gazebo New also has that, but it's not. It's kind of like that is the realm of CAD tools, So we're trying to focus on maybe making the export from CAD tools to Gazebo better, and not necessarily improving Gazebo's own model editing capabilities, but there's some feature there.
All right. Yeah. Good to know. Yeah, I guess like it's like how more complicated your robot is that you need to set up, the more complicated it is to make the SDFL or the FL. So yeah, I guess like things can be improved, or more tooling can be implemented. But I guess like Tim is then saying, like you need the CAD model to import, but then perhaps there needs to be an easier way to define the controls and physics of the vehicle. Yeah, I guess that's a good point. I'm hoping you're getting a lot of input from this, from for the
Yes,
Gazebo
absolutely.
team. Yeah.
Taking notes.
All right, so let me just because I was missing a couple of questions in the chat. Simulation of electronics, battery modeling, voltage sag, or even motor performance. Yes, indeed. I've put them on the list. It's very, very important as well. Yeah, I think we have to maybe we have to kind of watch the time here. I think we can still keep on discussing for a few more minutes, but 5 till the end. I would like to also like do the regular announcements, if that's okay. So let's see if there's anything else. Is there anything missing, you think, from this list? Like we have quite a lot of things there. Is there anything that anybody would like to add? So ground control simulation needs to be part of the simulator. I'll add that too, although that might be yeah, I guess like that might be also like maybe an autopilot specific thing, I would say. But like ground control simulation. All right, ground station. Oh yeah, and of course like the CAT, high ET interfaces, ground control, ground station. All right, I think that's it. And of course, like if anybody else thinks there's more things missing, there is of course like connected to the discourse thread of this meeting. I've also started up like a separate thread for just discussion about simulators. So if there's anything else missing, you can add it there. So we can keep on discussing of what is missing in the general. But I kind of feel that we're probably going to have another meeting about this at one point as well. Yeah, I don't know, like if anybody wants to kind of like discuss about the rendering versus dynamic model versus parallelism. To be honest, like I feel that most of you are more fond of, let's say, the physics model needs to be pretty accurate, and that the vision model is like it should be kind of realistic, but it's not going to be realistic enough for the real thing anyway. I don't know, like if that's a good yeah, Mayank, go for it.
It depends on the use case. If I'm building something with VIO inside a warehouse, I want the visuals to be a bit more realistic as well, because I would go for some, like when it comes to self-driving cars, Carla and all are better because they use the Unreal Engine. So if I'm doing vision-based stuff beyond, let's say, some basic optical flow, and I'm building like a SLAM pipeline for indoor navigation, then I would definitely want the visual part. Like I'd focus on that sort of a simulator. But if it's outdoors,
using an Unreal rendering engine.
Yeah, like a much better rendering engine, which would give me the camera inputs, which are very similar to photorealistic, basically, so that the sim to real gap is the least. But if it comes to like relying on outdoor flights which are GPS driven, then it's okay if the sim looks slightly Minecrafty, I guess.
The Minecraft. Yeah, okay, yeah, I understand. It's like because you're flying all the way up high, it doesn't have to be super accurate if it has to. If it's an
Exactly.
outdoor GPS flight.
Yeah, I mean, it depends on the use case, right? Like, I mean, you could have mixed modalities wherein, let's say, when it's going for a landing maneuver and then you need your Aruko markers or QR codes to actually look photorealistic and good, then I would want that, because I don't want like a low resolution Aruko marker which is throwing off my optical flow or my landing like feature. But yeah, yeah, I think the photorealism aspect comes beyond like aesthetics. The functional purpose it serves is if you're doing a lot of vision based stuff. If your autonomy stack is more GPS and other sensor driven, then for example, if you're doing ultra wideband, I would want better network simulation, right? Because I'd want like a proper um, maybe a better physics simulation of the packet loss and other kind of aspects of those things.
Yeah, yeah, that's of course like accurate. I think there was Rotor S had a fork called Crazy S, which was for the Crazy Flies, who actually made their own ultra wideband simulator plugin for that for Gazebo.
Nice.
Not sure if they went all the way to packet loss though, but or
Yeah.
how do you call it, like wall bouncing off, or like that's metal in the environment.
Multipath propagation and fading and effects like that.
Yeah, exactly. Yeah, so that's I don't think they went all the way there, but
at least signal strength as inverse square law is the basic I would expect if I'm doing something using radio a lot.
Yeah.
Like even for the GPS, if I'm flying in an open environment, I'm good. But let's say I know I'm going to be running missions around a lot of mountains or near buildings, then multipath simulation would be a lot more important to me, because I know that's something I'll face every day in the operations.
Yeah, okay. For mountain navigation, I will put it right there. Yeah, I guess like rendering versus dynamics model versus parallelism. Yeah, parallelism is more of like, how fast is the simulator for swarms, and I guess also like for a part for reinforcement learning, but it's very very application specific. And then dynamics model, there's multiple out there, but it's more of like, if you're doing vision based navigation and you're just focusing on high level stuff, then the physics model doesn't need to be very complicated. But if you want to make a new controller that is top of the line, can recover from like any wind gusts whatsoever, then the dynamics model and the aerodynamics model of the effects is also going to be very important. Yeah, there's a lot of things to consider. It's a lot more to consider than I initially thought. I knew that already, but it's good to have kind of like, a nice discussion about that, like, how vast and wide this issue is. So maybe in the future, like once we have the role of robotic simulators paper out, then maybe I can give a presentation at this working group as well about that. At least like, the how we're all those as different aspects and how it's how they compare to each other. Mayank, yeah.
Sorry, I just meant to clap and I ended up using my hand.
Okay. Yes. Thank you. Okay, so I'm really going to then start with the final part of this meeting. I'm really happy with all the discussion so far. I think it's very good to kind of really make an outline and really have maybe perhaps an idea, like, where to focus on at one point. So of course the announcement, ROSCON 2023 next week. Who's going? Just raise your hands or do a clap or something like that. So nobody's going? This is going great. I'm unfortunately not going. I'm very sad to say that I'm not able to come. I was looking forward to all week, but unfortunately I have some personal circumstance that doesn't allow me to go. So next year I'll be there. But I'll just like, of course I want to like anybody that's able to go there. It's wish them a lot of luck and a lot of fun, of course. So there are 2 presentations that Thursday that you shouldn't miss, either on the site or maybe as a stream if that's available, which is the Thursday keynote is Up and Away, Adventures in Aerial Robotics by Ramon. And I also helped a lot out with preparing that talk as well. And at 10 o'clock, it's going to be Aerostack, my Miguel. So he also joined some meetings before about Aerostack too. So you should also kind of join that and support the air robotics community. All right, next meeting. So the very next meeting in 2 weeks is cancelled because it's just going to be right after ROSCON and we all need a breather. I'm also not able to participate myself. So the next one is going to be Wednesday, the 8th of November, 2 p.m. Universal time. And be aware of the daylight saving. So the people in Europe and India and things like that, it will probably be like an hour earlier than usual. So 2 p.m. Universal time. And the scientific presentation, Ramon will actually give a presentation about PX4. So that's going to be nice. So GitHub organization, the link is right here, github.com ROS Aerial, where we have the Aero robotic landscape with the link of like simulators and things like that you can just change if you want, just make a PR. As a community information with the meeting information, and you can add yourself as a member. Anybody can join at this point. This is a community working group anyway. And if you want to do a presentation or a scientific presentation about your project with aero robotics and ROS, or just want to like show what you're working on, or like a PR that you're working on, or something like that. Yeah, give me an email, Kimberly at bitgrace.io, or Ramon or Roach at linuxfoundation.com. And that's it. I think this was a very nice discussion. So thanks again today for joining.